functions. Okay, something we keep learning for year 10, year 11, year 12 is the unit circle. So what's the definition for unit circle? It's a circle of radius of 1, center at 0, 0. It helps us to find all these sine and cosine values by using that unit circle. So if you still don't understand how unit circle works, I'll just go one last time with you. In the Cartesian plane, we have a unit circle of center at 0, 0, radius of 1. We draw that circle and then we sketch an angle. Okay, we draw an angle. How do we define angle? Since we from the positive x-axis and go anti-clockwise. Let's say we sketch a 30-degree angle. Okay, we sketch a 30-degree angle. Which the angle is here. That gives you 30 degrees. Okay, that gives you 30 degrees. And then I can find a point of intersection here. Even though you can't really like calculate what is the angle, okay, you can calculate it by using the circles equation and the linear equation. You can actually do that, but like we are not really interested to let you know do that. You can find the coordinates here. So the coordinates for this one will be √3/2, comma a half. That will be the coordinates. I tell you that line and the circle intersects at that point. And I know the x value will be the cosine of that angle, and the y value will be sine of that angle. Okay, sine of that angle. So therefore, we will have the cast thing CAST. Okay, so any angle in the first quadrant will have positive sine, positive cos, and positive tangent value. Any angle in between the second quadrant, you only have positive sine, because in that quadrant, x is negative, y is positive. So you will have sine over cos, so it's y over x will be negative. Therefore, only y is positive. Y represents the sine value. So in this quadrant, only sine is positive. So same happens for the third quadrant. Both x and y are negative. So both x and y, cosine and sine values are negative for the third quadrant's value. But the tangent will be y over x, which is positive. So tan will be the only positive value in the third quadrant. In the fourth quadrant, x is positive, y is negative. Therefore, cos is positive, sine is negative, and tangent will be negative. And tangent will be negative. That's for the fourth quadrant. Okay, so that's unit circle. The next thing is the radian. How do we define radian? So what is radian? One radian we written as 1c. Is the angle subtended at the center of a unit circle by an arc length of 1 unit. Okay, so what is one? I'll just sketch another unit circle. What is one? Okay, I'll say that's a circle with radius of 1. Okay, that is a circle with radius of 1. And what is 1 radian? How large is that angle for 1 radian? I will have an angle here. If I say that arc length, okay, this one, that length equals to 1. If say that length equals to 1, this angle is called 1 radian. This angle is called 1 radian. Therefore, we have another unit circle. We have another unit circle, and that's the center. Okay, that's radius of 1. Okay, radius equals to 1 from here to here. Radius is 1. So the circumference equals to 2 pi r, which is 2 pi. So half of the circle got radius or got circumference of pi. Okay, this green area, okay, this green bit has length of pi. Okay, half of the circle has length of pi. Therefore, the angle subtended by this arc will have pi radian. Okay, arc length of 1 give you an angle of 1 radian. So arc length of pi will give you an angle of pi radian. Therefore, pi radian will equals to 180 degrees. Okay, pi radian will equals to 180 degrees. That's how we set up, how we find the relationship between the degree and the radian. Okay, that's how we find the relationship between degree and radian. Because the half circle got circumference of pi. Okay, the full circle is 2 pi, the half circle is pi. The angle subtended by that arc will be pi radian. And that half circle will be 180 degrees. So pi will equals to 180. Pi will be equals to 180. So 2 pi will be 360 degrees. And then we have 1 radian equals to 180 divided by pi. 1 degree will be pi over 180. Okay. That's the conversion between the angles and in degree and the radian form. Let's have a look at next one. Next one is we introduce unit circle and I have go through everything with you. The intersection have x value and y value. X value is the cosine value, y value is the sine value, and the tangent is the sine over the cos value. Okay, so we have the cast, C-A-S-T, we have the C-A-S-T, the cast value. And we have definition of special angles. So what are special angles? Special angles is the value you can write in the exact form. Okay, you can write sine, cosine, and tangent value in the exact form. So we have two groups of special angles. The first group is the multiple of 90 degrees. So any angle lies on the axis will be a special angle. So for example, we have sine 0 degrees. Sine 0 will be 0. Okay, sine pi over 2 will be 1. Sine pi will be 0. Sine 3 pi over 2 will be negative 1. Cosine 0 will be 1, cosine pi over 2 will be 0, cosine pi will be negative 1, cosine 3 pi over 2 will be 0. That's how we find all of that by using unit circle. Okay, we see all of that by using unit circle. Tangent 0 will be 0, which is sine over cos. Tangent pi over 2 will be undefined because the denominator is 0. 1 over 0 is undefined. And tangent pi will be 0 over negative 1, which is 0, and tan 3 pi over 2 will be undefined. Denominator is 0. Okay, have a look at those examples. I want to evaluate those values. So those values are all multiple of pi on 2. Say, in other words, it's the multiple of 90 degrees. So for those type of angles, I need to find where are they first. Okay, so where are they? Negative 3 pi over 2. So it's 3 lots of pi over 2 degrees. Okay, so that's the first one. That's the negative pi. That's negative 3 pi over 2. So this angle will be here. Okay, the angle will be here. So this green bit go negative direction, so I'll go clockwise, not anti. So go clockwise is negative. So negative 3 pi over 2 is there. That coordinates, if that intersects with the unit circle, the coordinates will be 0, 1. Sine value, sine represent the y value, so that equals to 1. Okay, that equals to 1 because it's the y value. Okay, so it's 1. Cosine negative pi on 2. Okay, cosine negative pi on 2. So anti-clockwise, which is here. That is the angle, okay? That is the angle. Negative pi over 2. That is 0, negative 1. So cosine negative pi over 2 will be 0. pi over 2. So that's sine 2 pi plus pi over 2. If you have 2 pi, okay, multiple of 2 pi, you can just don't worry about the 2 pi. You can get rid of it. You just have sine pi over 2. Sine pi over 2, the angle is here. That coordinates is 0, 1. Y value is sine value, so sine pi over 2 is 1. Okay, it's cosine 7 pi over 2. So I can say that's cosine 4 pi minus pi over 2. Okay, cosine 4 pi minus pi over 2. Why I go cosine 4 pi? Because I want multiple of 2 pi. Okay, I want multiple of 2 pi. So that will equivalent to cosine negative pi over 2. I can get rid of the 4 pi. I can get rid of the 4 pi. So it's negative pi over 2. So negative pi over 2 will be this angle here. Let's go that direction. Then that is 0, negative 1. So cosine negative pi over 2 will be 0. Tangent 5 pi. Well, tangent 5 pi will be tangent 4 pi plus pi. That will be tangent pi. Okay, tangent pi. If for tangent, if the value lies on the axis, okay, that direction, that will just be 0. Okay, tangent pi was just 0. Okay, for this one, that equals to tangent 4 pi plus pi over 2. That is tangent pi over 2. If it's tangent pi over 2, it lies on the y-axis. Okay, it lies on the y-axis, then it's undefined. That's undefined. Because that is 0, 0, 1. So sine over cosine, so 1 over 0, which is undefined. Okay, 1 over 0, which is undefined. Okay, the next one is further symmetry properties and Pythagorean identities. Okay, so further, there are about 12 formulas. I don't want you to remember those 12 formulas plus later on we have another 4. So I don't want you to really remember that. I just want you to find a way to really sketch it and then can really prove that by yourself. Okay, for first angle, let's have a think. We want to know sine pi minus theta. Okay, the thing is, for any evaluation of sine, cosine, and tangent values, I always want to see the reference angle. I hope you know what is reference angle now. So let's have a think. Pi minus theta. If theta is an acute angle, where will be pi minus theta? In which quadrant? Second. Okay, if it's in the second quadrant, I have angle here. And I say that this angle is pi minus theta. The reference angle is the angle line made with x-axis. Okay, the angle line made with x-axis. Therefore, the reference angle will be this angle. That angle will be theta. Okay, in total that will be pi. So that is pi minus theta, then the little bit will be theta. Therefore, the reference angle for pi minus theta will be theta. That quadrant is the sine quadrant. Okay, that quadrant is the sine quadrant. Therefore, we have sine pi minus theta. I can change that to sine theta. Change the angle into the reference angle directly. And that's a positive one because that's the sine quadrant. But when we evaluate cosine, that will be negative cosine theta and negative tangent theta. Because they have the same reference angle, but the quadrant is sine quadrant, for tan and cosine will be negative. Okay, for cosine and tan, that will be negative. Have a think about the next one, pi plus theta. Okay, again, let's treat theta as an acute angle. If theta is an acute angle, then pi plus theta will be this angle here. Okay, pi plus theta. Therefore, the reference angle will be this angle here, made with x-axis. Okay, it's never made with y-axis. It's always made with x-axis. And therefore, we have angle theta as well. This quadrant is the tangent quadrant. So all the angle will be changed into theta, but sine will be negative. Cos will be negative, but tangent will be positive. Okay, we change the angle pi plus theta into the reference angle theta, and then we try to choose the correct quadrant. Okay, it's the tangent quadrant, so only tangent remain positive. Okay, 2 pi minus theta. So 2 pi minus theta. That will be an angle here. Okay, whole angle here is 2 pi minus theta. Therefore, the reference angle will be theta. Reference angle will be theta, okay, made with x-axis. And this is the cosine quadrant. Okay, this is the cosine quadrant. So sine 2 pi minus theta will become sine theta. But it will be a negative. Cosine just become cosine. And tangent will become negative tangent. And also we have negative theta. Okay, for negative theta, I will have angle here in the fourth quadrant. Okay, we have this direction is negative theta. Okay, the angle will come in that direction. But the reference angle is still this angle. Okay, it's the same reference angle, also theta. Okay, for reference angle, we don't think about this positive or negative. We just think about how large is that angle. Okay, reference angle is always positive. Reference angle is always positive. So that size is theta, magnitude is theta, but go this direction, that y become a minus theta. But when we think about the reference, we just think about how large is that angle. It will be the same as 2 pi minus theta. Okay, it will be the same as 2 pi minus theta, because minus theta and go another circle by 2 pi, it will be the same position. Therefore, you will have all the same formulas as before. Okay, those two are the same. Those two angles actually the same angle. Okay, lies on the same place. So that's the 12 formula you need to know about. Well, you don't really need to remember them, but you need to know how to use a method to find them. Okay, example 2. Sine pi minus x. Sine pi minus x will equals to sine x by using the formula before. Pi minus x will be angle here. Pi minus x. Then the reference will be x here. So we'll change it to the reference angle x, and also this is the sine quadrant, it will remain positive. Therefore, that just equals to 0.6. For this one, that equals to minus sine x. Okay, pi plus x is here. And then reference angle will be x. But this is the tangent quadrant, so it's a negative of that. So it's negative 0.6. 2 pi minus theta, that equals to minus sine x as well. It will be the same as that one, minus sine x. They all equals to negative 0.6. Okay, by all using the same method as above. Okay, further properties. There are 4 more symmetrical properties, and there are 1 Pythagoras identities. Okay, so first one is sine 90 degrees minus theta will give you cosine theta. Cosine 90 degrees minus theta will give you sine theta. Those two are actually really helpful. Okay, those two formulas are really helpful for some type of questions, especially to do transformations between sine and cosine. There's one special type of transformations I haven't really mentioned to you before. I said like only same type of equations can be transferred to each other. There's one exception is the sine to cosine graph. Okay, sine can be transferred to cosine graph, and that formula are really important to transfer the graph. Okay, so you need to know that two properties. Okay, there's not a really good ways to remember it. You just need to memorize it. But it's quite easy to understand. Sine 90 minus theta will be equals to cosine theta. Cosine 90 minus theta will equals to sine theta. You can think about the thing in the right angle triangle. One angle will be theta, the other acute angle will be 90 minus theta. And the sine value will be cosine of the other angle's value. Okay, so think about that. If you have theta here, this angle will be 90 minus theta. Let's go pi on 2. Pi on 2 minus theta. If you say that's A, that's B, that's C, well, sine theta will equals to B over C. Cosine pi over 2 minus theta will equals to B over C as well. Those two values are the same. Therefore, cosine pi over 2 minus theta will equals to sine theta. And you can prove the other way as well. Sine theta equals to B over C. Cosine pi over 2 minus theta equals to B over C. Therefore, sine theta equals to cosine pi over 2 minus theta. Okay, that two, just basically purely remember them. For the next two, pi plus theta, pi over 2 plus theta, 90 degrees plus theta. Okay, let's have a look. Where is this angle? Okay, let's see if theta is in an acute angle, which quadrant it will be in. Which quadrant? Second. Okay, second. If you have that in the second quadrant, we have this angle here. Okay, that is pi over 2 plus theta. Okay, this will still be the reference angle. Okay, this will still be the reference angle. How large is that angle? In total is pi. And that angle is pi over 2 plus theta. What do you think this one? The whole thing is pi minus that angle. What that gives you? Pi over 2 minus theta. Okay? The reference angle is pi over 2 minus theta. It's an acute angle. So let's have a think of this formula. Okay, let's think of this formula. Sine pi over 2 plus theta. This is the sine quadrant. Okay, this is the sine quadrant. So I can change it to sine of the reference angle. I can change the reference angle instead of the whole angle. So I have pi over 2 minus theta. And what is sine over 2 minus theta? That's cosine theta by using the previous two formula. So sine pi over 2 plus theta will equal to cosine theta. And let's think about the cosine one. So cosine pi over 2 plus theta. Okay, if you talk about cosine, that is in the sine quadrant, I'll have negative cos. And then pi over 2 minus theta. What's cosine pi over 2 minus theta? That's sine theta. So cosine pi over 2 plus theta equals to negative sine theta. Okay, still use the reference angle theory to work out the formula. Okay, the last one is the Pythagorean identity. Pythagorean identity. Well, you know that it's a unit circle. Okay, you know that it's a unit circle. Like, let's say we have anywhere. Okay, this is the x value. This is the y value. Here is 1. X squared plus y squared always give you 1 square. X represents the cosine cosine theta value. So cosine squared theta plus sine squared theta will always gives you 1. Okay, sine squared plus cos squared will always be 1. Okay, next one. If you have cosine equals to negative 0.4, let's say that's negative 2 over 5. Okay, cosine theta equals to negative 2 over 5, negative 0.4. And the angle is in between pi and 3 pi over 2. The angle is in between pi and 3 pi over 2. And ask you for sine value. Okay, if you know the cosine value, you can find any value like sine and tangent, you can find any value. But like give you sine to find cosine or give you cosine, ask you to find sine, you need to use the Pythagorean identities. Okay, Pythagorean identities. And be careful, there's a particular way you need to write this. So we will have sine squared theta plus cosine squared theta equals to 1. Therefore, sine squared theta plus negative 2 over 5 squared equals to 1. Sine squared theta equals to, okay, that's 4 on 25. 25 minus 4 is 21 on 25. Okay, what sine theta equals to? What sine theta equals to? What do you write for this step? Okay, you need to have the plus minus of square root 21 on 5. You must write the plus minus in the step. You don't take the theta, how large is the theta, into consideration yet. Okay, this is just purely calculation. For something square equals to a number, that thing just can be plus minus of that. That's worth 1 mark. Okay, this line worth 1 mark. And the next thing is you need to discuss. Okay, because your theta is in between that, so sine theta value will be negative. That's in the third quadrant. Okay, that's in the third quadrant here. That's the tangent quadrant. You will have negative values. So therefore, sine theta equals to negative root 21 over 5. Okay, so that's why that equals to negative root 21 over 5. You can't directly write negative root 21 over 5 at that step, last step, like here. You can't directly write negative here. You need to have plus minus first, and then talk about the angle, and then choose the value you want. Okay, that's the way you need to write your answer. Okay, that's the way you need to write your answer. Okay, next one is tangent theta. Okay, at any time, tangent theta will equals to sine theta over cos theta. At any time. Okay, sine theta is negative root 21 over 5 divided by cosine theta is negative 2 over 5. That equals to root 21 over 2. That equals to root 21 over 2. Tangent is positive. Okay, tangent should be positive because it's in the third quadrant, and tangent should be a positive value. Okay, cosine pi over 2 minus theta will be a sine pi over 2 minus theta will give you cosine theta. And cosine theta equals to negative 0.4. Cos pi over 2 minus theta gives you sine theta, and sine theta is negative root 21 over 5. Okay, that's just you need to remember the formula. Sine pi over 2 plus theta, that will gives you cosine theta. And that's negative 0.4. Cosine pi over 2 plus theta using the formula that's negative sine theta. Okay, cosine will go to negative sine. That's negative sine theta. That's root 21 over 5. Root 21 over 5. Okay, these are actually 6 formulas. Okay, 4 of the symmetrical property, 1 for Pythagoras identity, and 1 for tangent. Okay, tangent is always sine over cos. Tangent is always sine over cos. Okay, exact values, special angles. As I said, group 1 special angle will be those angles with multiple of pi over 2. Okay, so multiple of 90 degrees. Those angles lies on the x-axis or y-axis. And now there's another type of angles with reference angle is 30, 45, and 60 degrees. Okay, 30, 45, and 60 degrees. Why 30, sine 30, 45, and 60 are special angles? Because we have 2 types of special angles. One type is those angles with 45 and 45 degrees. I can say that's 1, 1, and root 2. Another type of triangle is the really equilateral triangles. Let's say we suppose the length is 2, then half of that, this length will be 1. Here gives you 30 degrees, here gives you 60 degrees, and then this one is root 3. Okay, I have 2 types of special triangles help you to calculate the sine, cosine, and tangent of 30, 45, and 60 degrees. That's why those 3 angles are special angles. You can find the exact format of those circular trig ratios. Well, I'm not going to show you. I just showed my year 10 last week how to do this. I don't think you really need that. But I will tell you, like, if you have a table, right, sine, cosine, and tangent in the vertical, and you have 30, 45, 60, like pound 6, pound 4, and pound 3 in a row from smallest to largest. I can have 1 on 2, root 2 over 2, and root 3 over 2. So the first line you have root 1, root 2, root 3 over 2. Therefore, the next line will be root 3 over 2, root 2 over 2, and root 1 over 2. So it's totally opposite way. Okay, it's totally opposite way. So root 3, root 2, and root 1. So the first row is root 1, root 2, root 3. The second row is root 3, root 2, and root 1. Then the last row will be the first row divided by the second row. Okay, first row divided by the second row. So you have 1 over root 3, which is equivalent to root 3 over 3. This one equals to 1. That one just equals to root 3. So if you can't remember your exact values, what you need to do at the beginning of the exam is you quickly set up this table and put it there, and then you can look up all the values. So make sure you have a correct table. So root 1, root 2, root 3 over 2 for the first row, root 3, root 2, root 1 over 2 for the second row, and the third row will be top divided by the bottom. You have 1 on root 3, 1, and root 3. Okay. So let's evaluate all of those special values. Cosine 210 degrees. Cosine 210 degrees. So 210 will be an angle in the third quadrant with reference angle 30 degrees. Okay, third angle is 210 degrees. Reference angle is 30. That is the tangent quadrant. Therefore, I will have cosine 30 degrees and I have a negative cosine 30 degrees because it's in the tangent quadrant. So that gives me negative root 3 over 2. Cosine 30 is sine 60. Sine 60 is root 3 over 2. Okay, sine 150 degrees. Sine 150 degrees. Sine 150 will be an angle in the second quadrant, which is here. That angle is 150 degrees. You have a reference angle of 30 degrees made with x-axis. This is the sine quadrant. So you will have sine 30 degrees, and that is a half. Okay, tangent 330 degrees. Tangent 330 degrees is in the fourth quadrant. Have the angle here. That angle is 330 degrees. The reference angle will be this angle here. That is 30 degrees. This is the cosine quadrant. Therefore, I will have a negative tangent 30 degrees. That is negative root 3 over 3, or negative 1 root 3. You will rationalize the denominator. So you have root 3 over 3. Okay, that's angle, talking about angles in degrees. And then let's talk about angles in radian. Okay, talk about angle in radian. So 5 pi over 4. So it's pi plus pi over 4. Okay, it's pi plus pi over 4. So you will have pi is here and then pi over 4 is here. So you have this angle here, that's 5 pi over 4. And the reference angle will be here. That's pi over 4. This is the tangent quadrant, so you have tangent here. So cosine will be negative. Negative cosine, reference angle is pi over 4, so it's negative cosine pi over 4. So it's negative root 2 over 2. It's negative root 2 over 2. Next one is 11 pi over 6. Okay, 12 pi over 6 is 2 pi. So 11 pi over 6 must be in the fourth quadrant. Must be in the fourth quadrant, which is here. Okay, this big angle is 11 pi over 6, almost 2 pi. Reference angle will be this one, pi over 6. Okay, pi over 6 is the reference angle. And this is the cosine quadrant. I want to know the sine value. That is negative sine of pi on 6. That's negative a half. Okay, that's negative a half. The last one is 7 pi over 4. Okay, last one is 7 pi over 4. 7 pi over 4. 8 pi over 4 is 2 pi. Therefore 7 pi over 4 will be somewhere here. So this one is 7 pi over 4. And the reference angle will be pi over 4 here. Okay, reference is pi over 4 here. And that's the cosine value. That's the cosine quadrant. Then tangent will be negative. So it's negative tangent pi over 4. And that's negative 1. And that's negative 1. So you need to really remember the special angles. You need to be this quick. Okay, so at once you need to give me the value. So it's all about timing. Okay, the last final exam is about time. Okay, you need to remember that and really do it quickly. You don't want to type those things into the calculator and see the value. It's too waste of time. Okay, so really need to remember those values. Okay, next thing we are talking about is the graphs. Okay, it's the graphs. Well, my way of sketching the graph might be a little bit different from what you learned last year. So I'll use some trick. Okay, I don't really see the transformation. I don't like to sketch graph by using transformation. You can see, like, I'm teaching you all the graphs. It's not by seeing the transformation. I always find some key features and then just complete the graph directly. So sine, cosine, tangent graph is the same. So for the sine and cosine graph, okay, first we will have a really complex equation, which is a times sine and loss of t plus minus epsilon and plus or minus b. Okay, this should be in the bracket. Okay, that thing should be in the bracket, and b is moving up and down. So what is A? A is the amplitude. What amplitude affect you? Amplitude affect the maximum and minimum. What is the n affect here? The n affect the period. Okay, 2 pi over n period equals to 2 pi over n absolute. Okay, 2 pi over n absolute. You can have a negative n, but you won't have a negative period. You always have a positive period, so the n should be in absolute values. And epsilon here, like this little symbol here, it represents the horizontal movement. Okay, the graph moves to the right, moves to the left. Okay, when we sketch the graph, we don't really interest in that, and you can just ignore that value. Well, you can't really just totally ignore it, but like we don't really use that value to sketch the graph. And you have this B. B is the mean line. Okay, where is the middle of your graph? B is moving up and down. Like normally your graph middle will be 0, so moving up and down by B units will be the mean line. So B is the mean line. It's the vertical movement. So 3 important things is the amplitude, period, and the vertical movement. Okay, vertical movement. That will influence the shape of your graph. Okay, that influence the shape of your graph. Okay, let's have a look. This is a sine graph, and the bottom is a cosine graph. Okay, I put colors on it. You can just have a look at my graph. Okay, in each period, this graph experiences 4 parts. Okay, the first part is increasing. Okay, from the mean increase to the maximum. The next bit will be from the maximum reduced to the mean line. And then the next is the mean will reduce to the minimum. And the minimum will go back to the mean line. If you keep going with this pattern, the next thing will go into the maximum. The next thing will go into the mean and the minimum. So sine graph and cosine graph is always follow this pattern. Okay, sine cosine graph always follow this pattern. It's always the max, mean, minimum, mean, max, minimum, mean, minimum, mean, maximum. So always keep going like that. Cosine is the same. So in each period, this, like say I have a point. This point will move 4 times. Okay, move 4 times from the max to the mean. From the max to the minimum, mean to the minimum, minimum to the mean, and mean to the maximum. That will experience 4 stages. And okay, if you know a point already at the maximum, okay, if you know a point at the maximum, you will definitely know where the point will go next. It must go to the mean. Okay, it must go to the mean. How long it takes you to go to from the max to the mean is period over 4. You will take that many lengths to travel from the top to the mean line. Because in each period, your graph will experience 4 stages. Each stage will be period over 4 of the length in horizontal. Then vertical, you move from the max to the mean. Again, then the next stage must be mean to the minimum. You will take another period over 4 of the length to travel from the mean to the minimum. So, okay, so my whole idea of sketching cosine and sine graph is you find one point at the maximum or minimum. One point is enough, and you can complete the whole graph. Okay, you don't need to think about transformation at all. And how we can find a maximum or minimum point. I'll show you an example. It's like seems like quite like not make sense, but like I will show you why this really works well. Let's have a look at the steps for sketching sine graph. Okay, I have listed out some point like how you can sketch a sine graph. First 3 things is easy. First 3 things, label the mean line, label the maximum, and label the minimum. Those 3 things are easy. Okay, label max, label mean, and label minimum. So let's have a look at example 1 here. Okay, let's look at example 1 here. For this graph, can you tell me what is the mean line? 2. Okay, mean line is 2. So I will sketch a line at 2. Well, you can use pencil to sketch it. And where is the maximum? Where is the maximum? 5. And where's the minimum? Where's the minimum? The amplitude is what? 3. Okay, mean line is 2. 2 go down by 3 units. Where is it? -1. Okay, we have -1 here. Okay, my graph will be in between this part. Okay, my graph will be in between this. And the next thing is the magic part. I want to find a maximum point or a minimum point. Okay, you just need to remember this step and you can complete most of the graph. Okay, so I will ask you, sine what gives you 1? Sine what gives you 1? Pi over 2, okay? Sine pi over 2 gives you 1. So this is like, have a look at this equation here. Sine of something. This red circle, the maximum value will be 1, right? Sine of anything, the maximum will be 1. Doesn't matter what equations you have inside the bracket. The maximum value will be 1. So sine something will be 1, will give you the maximum value, right? Otherwise, all the value will be 0.2, 0.3, 0.8 is all point something, and -0.2, 0.3, -1 is the minimum. So if you can have that red circle become 1, you will achieve either a maximum or a minimum value. So how that red circle can achieve 1? That is when 2t minus pi over 4 gives you pi over 2. When the whole thing in the bracket become pi over 2, that's a sine pi over 2. And that red circle will achieve 1. Okay, that red circle will be 1 for sure. So everything in the bracket become pi over 2. Then sine of that bracket just become 1. And you can achieve extreme value, either maximum or minimum. So I'll solve for t here. T minus pi over 4 equals to pi over 4. And t just equals to pi over 2. Okay, at t equals to pi over 2, this graph will have either a maximum value or a minimum value. Depends on the amplitude. Okay, the a times in the front. If a greater than 0, you will achieve a maximum. If a is less than 0, you will achieve a minimum. Okay, whether you achieve maximum or minimum, it depends on the number you times in front of this sign. If, like, think about if that's a -3, and then the red circle become 1. 1 times -3, you have -3, and 2 minus 3, you have -1. That's the minimum value. Okay, that's the minimum value. But let's say if a is positive, 1 times a positive number is positive. Positive plus the midline, that will give you the maximum. So now you know that this point will be the maximum point. Because your a is 3, that will be a maximum value. So what you can put on is, where's pi over 2? Pi over 2. Here is pi over 2. And you will have a maximum. Then this point will be here. Okay, then this point will be there. That is a maximum. Okay, next thing is, you know that the next step will move to the midline. But how long it takes you to move from the max to the min is the period over 4. Okay, period over 4 of the length can make the point from the max to the min. So I will calculate the period for this graph. Period equals to 2 pi over 2. Okay, the n value is 2. That is the n value. So it's 2 pi over 2. That gives you pi. Then each step will be pi divided by 4. Okay, each period your graph will be experienced 4 stages. Then pi over 4 will be the horizontal lines it will take from the point to change from the max to the min, or change from the min to the minimum. So let's just say, like, the person, you need to take a step of pi over 4 every time to change your position. So where's pi, next pi over 4? Okay, it will ask us to sketch the graph in between power 4 to 5 pi over 4, 5 pi over 4. So on the horizontal x-axis, next power 4 will be here, next power 4 will be here, and next power 4 will be here. And then go to the left, next power 4 will be here. And you can see that a step of pi over 4. Okay, that's a step of pi over 4. And you know, if you horizontal take a step of pi over 4, the point will move as well. So this point will move to the mean. And from the mean, the next step we will move to the minimum. And then we'll move to the mean as well. Okay, you follow this pattern to move. And then go to the left. Okay, have a left endpoints as well. Left endpoints as well. For the left one, you will have moving to the mean as well. Okay, it's mean to the max. Okay, max go back to the mean. And therefore, you can really complete this graph by connecting all of that. You know what the graph will look like. Okay, that's the shape of the graph. And it's quite easy to label all the points. Pi over 4, 2, that's the end point. And pi over 2, 5, that's the max. 3 pi over 4, 2 is the middle point. Pi, negative 1 is the minimum. And 5 pi over 4, 2 is the end points. And you can take off the 3 lines and the graph will look like that. Okay, if you have difficulties of sketching graphs, try this method because I feel like a lot of students feeling this method is actually working for them. Okay, if before you have difficulties with sketching sine cosine graph, try this one. Okay, this one all require you is finding points and finding the steps and match them together. Can match them together. Okay, that's a sine graph. Well, I don't have enough time to go through the next example, so next lesson I will go through the cosine graph with you. Or you can have a try of cosine graph. The only difference between draw a sine graph and cosine graph will be you will set up the inside become 0 instead of pi over 2. Because cosine 0 will give you 1. You want the maximum value, that inside needs to be 0 instead of pi on 2. So here will be cosine 0 gives you 1. You can achieve a maximum or minimum point. Okay, so you can have a try of example 2 by yourself. Okay, you can try example 2 by yourself.